Hello everyone, myself Diksha Anand, Assistant Professor, Department of Civil Engineering, AJIT Mangalore. In continuation with the last class, that is about Module 2, hardened concrete, we have already discussed some of the topics in Part 1, and now moving on to Part 2. These Part 2, what are the topics I'm going to include in this class is in page number of the notes what I have given, that is in page number 12 to page number 21. So moving on to the topics what we'll be discussing in this: factors affecting the creep. So the magnitude of the creep depends on mainly aggregate, water cement ratio, size of the specimen, temperature, intensity and duration of the stress, type of cement, humidity of the ambient air, moisture content of the concrete, and age at the time of loading. So we'll discuss one by one what are the factors, or what are the effect or the magnitude of the creep that depends on. So the first one is aggregate. So normally aggregate undergoes very little creep, and it is the paste which is responsible for the creep. So it is the paste which is responsible for the creep. However, the aggregate provide the restraint effect when paste undergoes the creep. The modulus of elasticity of the aggregate is also one of the important factors influencing the creep. The higher how this modulus of elasticity depends on the aggregates or the magnitude of the creep. The higher the modulus of elasticity of the aggregate, the less is the creep. Lightweight aggregate shows considerably higher creep than normal weight aggregate because of the lower modulus of the elasticity. It has been found that greater the maximum size of the aggregate, the less is the creep of the concrete. So these are the points. Water cement ratio. The second one, the factor which affects, that is water cement ratio. Higher the water cement ratio increases the size of the pores in the paste structure. The amount of the paste content, its quality, is one of the important factors influencing the creep. Creep increases with increase in the water cement ratio. Also, all the factors which are affecting the water cement ratio, the creep of the concrete. So the next one is age at the time of loading. The quality of the gel improves with the time. In such gel, creeps are less. Initially, gel undergo loading, load being not so stronger, creeps more. Hence, creep decreases with the age of the concrete. Next, type of the cement is also one of the factors or the magnitude which affects the creep. So, the type of the cement influences the creep is so far it influences the strength of the cement at the time of application of the load. Under drying condition, Portland blast furnace slag cement results in the higher creep than the usual type of the Portland cement. Next one, that is moisture content. Increase in the moisture content of the concrete increases the creep. So as the moisture content increases in the concrete, it increases the creep. So next is humidity of the ambient air affects the seepage of the moisture from the concrete, An increase in the humidity reduces the rate of loss of moisture and this reduces the seepage. Thus, the given concrete creep is higher, lower relative humidity drying of the concrete which under load enhances creep of the concrete. Next, what is the type of the cement, and here the finer the cement the higher is the gypsum requirement, so that regridding cement in the laboratory without the addition of gypsum produces improperly retarded cement which exhibits high creep. Intensity and duration of the stress. In many tests, a direct proportionality between creep and the applied stress has been found to exist, and it is found that the concrete is cured for 90 days and then loaded for 21 years showed 680, 1000, and 1450 into 10 to the power minus 6 creep strain corresponding to sustained stress level of 4 megapascal, 6 megapascal and 8 megapascal respectively. So next is size of the specimen. Next factor. The size of the specimen also affect the magnitude of the creep. So the magnitude of the creep, amount of creep decreases with increase in the size of the specimen. But as the size decreases, creep will get increase. This is due to the reduced seepage as the path travelled by the expelled water is greater with the visiting increase in the frictional resistance to the water from the is a temperature. Concrete is exposed can have two counteracting effects on the creep. If the concrete member is exposed to a higher than normal temperature as a part of the curing process before it is loaded, the strength will increase and the creep strain would be less than that of the corresponding concrete stored at the lower temperature. So the strength will get increased only when the concrete member is exposed to a higher temperature than a normal temperature as a curing process during a curing process, and the creep strain would be less than that of the corresponding concrete stored at the lower temperature. On the other hand, exposure to temperature during the period under load can increase the creep. So here the two scientists Nazir and Neville found that the stress strength ratio of 70%, the 350-day creep can increase 3 to 5 times if the surrounding temperature is raised from 21 degrees Celsius to 71 degrees hardened concrete. So as we have studied what are the tests done on ingredients of the concrete, ingredients of the concrete, as well as after collecting the ingredients we have moved to the fresh concrete. There also we have studied what are the tests done on fresh concrete to determine the properties, and now when the fresh concrete turns to the hardened property or hardened state, we have to determine the test or we have to determine the results of the hardened concrete, and the testing on the hardened concrete plays an important role in controlling and confirming the quality of the cement concrete work. So mainly we will be checking the strength property of the concrete. So first one, that is flexural strength of the concrete. So concrete, it is strong in, we all know that concrete, it is strong in compression and weak in tension. So if we take uh, a member or a concrete block, we cannot pull it, so that it is weak in tension. So but whereas if we go for a steel which is good in tension or strong in tension, because when we apply the load, instead of breaking, it get elongated. So in reinforced concrete member, little dependence is placed on the tensile strength of the concrete. However, tensile tensile stresses are likely to develop in the concrete due to dry shrinkage, rusting of the steel reinforcement, temperature gradient, and many other reasons. Therefore, the knowledge of the tensile strength of the concrete is important. Next one, that is a concrete, when we talk about a concrete road slab, is called upon to resist the tensile stress from two principal sources. So the first one, that is wheel load. Normally the wheel which supplies or applies load on the pavement surface and the volume changes into the concrete. Wheel loads may cause high tensile stresses due to bending when there is subgrade support. So volume change resulting from the changes in the temperature and the moisture may cause the tensile stress due to wrapping and due to the movement of the slab along the subgrade. Stress due to volume change alone may be high, and here it is given that uh, it is frequently as much as 2.5 megapascal at a certain period of year, and the corresponding stress in the transverse direction is approximately 0.9 megapascal. Next one, what are the types of test on the flexural strength? So the first one we are talking about the flexural strength of the concrete. Under flexural strength, what are the different types of tests to be done on the hardened concrete? So the first one is determination of a tensile strength of the concrete, and the second one is determination of a split tensile strength of the concrete. So first one we'll take determination of the tensile strength of the concrete. So tensile strength, if we go for a beam test, so we all know that how beams are casted. So beams is nothing but a reinforced structure, like we'll be having a reinforcement and inside that will be covering the concrete. So it is a measure of flexural strength property of the concrete. The value of the modulus of rupture, that is extreme fiber stress in bending, depends on the dimension of the beam and the manner of loading. So how we give the loading. The system of loadings are central point loading and the third point loading. And here in the central point loading, maximum fiber stress will come below the point loading where the bending moment is maximum. Next, in case of symmetrical two-point loading, the critical crack may appear at any section not sound enough to resist the stresses. And here when we cast a beam, the size of a specimen, it may vary, but here the normal size, if you go for a normal size, it varies from, or it stands for 15 into 15 into 70 centimeter. Alternatively, the normal size of the aggregate does not exceed. So we all know that what size aggregate we'll be using for any of the construction of a building. So usually we will be going with 16 size, but here it should not exceed 20 size. And the specimen 10 into 10 into 50 centimeter may be used, should be of metal, preferably steel or iron. Next, here we can see single point loading as well as 3-point loading, central point loading as well as 3-point loading. The permissible error should not be greater than 0.5% of the applied load where a high degree of accuracy is required. So here L is equal to 3D. So here we can see 3-point loading. 3-point loading. So here you can see 2 points and here the supports, and the distance from the end to the first support we have taken it as D, and next again from the central support to central support 2-point loading it is considered as D, so it is equally spaced. Therefore total L is equal to 3 times of D. But here in this for single point loading or the central point loading, so the load is acting at the center. So here this what is this is nothing but this is nothing but a beam which is under completion, and like load is applied, and here we have taken it is equally distributed central point loading L by 2, but we take the span length, it is taken as L. So here we have the procedure. The test specimen are stored in water, that is for curing purpose, at a temperature of 24 degrees Celsius to 30 degree for 48 hours, that's for 2 days. They are tested immediately on removal from the water. The bearing surface of the supporting and the loading rollers are wiped clean, and any loose material should be cleaned from the surface of the specimen where they are to make the contact with the rollers. And here the load is applied to the uppermost surface of the cast, as we know, and the mold along two lines spaced 20 or 13.3 centimeters apart, and the load is applied without shock and increasing continuously at a rate such that extreme fiber stress increases at approximately zero point 0.7 kg per square centimeter per minute. Per minute, zero point 0.7 kg should be applied on a centimeter square or the area. The load is increased until the specimen fades. So usually when we go for any of the tests, compression test or to determine the strength properties, we will go until the specimen fades, so that we have to increase the load. So here you can see locating bars removed from the loading commenced, and here 13 centimeters. So the rollers are 13.3 centimeters apart, and the roller diameter, that is 38 mm, and here the 2-point loads like end supports or the specimen is kept at a distance of 60 or 40 centimeter, and you can see the arrangement. All the rollers are of 38 mm dia. Arrangement of loading of flexural strength specimen, and here the load will be applied, and the load is applied until the specimen gets filled. The flexural strength of a specimen, that is modulus of rupture Fp, if A equals the distance between the line of the fracture and the nearest support measured at the center line of the tensile side of the specimen is centimeter, and it is calculated to the nearest 0.05 Newton per mm square or megapascal as follows. So here we have the formula. Fb is equal to PL divided by BD square, where A we have the value 20 centimeter for 15 centimeter and 13.3 centimeter for 10 centimeter specimen, and Fb is equal to 3Pa divided by BD square, and all the data are given. And here the description: B is equal to width in centimeter, D is equal to measured depth, L is equal to length in centimeter, and P is equal to maximum load in kg. So next is indirect tension test. Direct measurement of the tensile strength of the concrete is difficult. Neither specimen or testing apparatus have been designed ensure uniform distribution of the pull applied to the concrete, and the beam tests are found to be dependable to the measure flexural strength property of the concrete. So next is splitting tension test. Split tensile test, that is indirect tension test. So this test is carried out by placing a cylindrical. So we'll be going with split tensile test for a cylindrical mold or a cylindrical concrete mold horizontally between. So we have to keep the position, like we should not keep it vertically, we should keep it horizontally between the loading surface of a compression testing machine, and the load is applied until the failure of the cylinder along the vertical diameter takes place. When the load is applied on the element on the vertical diameter, the cylinder is subjected to a vertical compressive stress of, and we have the formula, 2P divided by pi LD into D square divided by R into D minus R minus 1. See, these are the formulas you need to remember, because if any question arises, like a problematic question, you need to apply. Like in some of the problematic question you may get the question like to determine the vertical compressive stress, so that you have to remember, you should remember what is vertical compressive stress and what is horizontal compressive stress. So you can see here a cylindrical mold cascade, and you can see here the white patches. So that is the pigment sulphate attack, so that you can study under durability. And here to test the split to determine the split tensile strength of a specimen, it should be kept horizontally, not vertically. You can see here how the specimen is loaded under the compressive testing machine. The loading condition produces a high compressive stress immediately below the load, but the larger portion corresponding to the depth is subjected to uniform tensile stress acting horizontal. And here it is said that compressive stress is acting about 1/6 depth and remaining 5/6 depth subjected to tension. And the packing strips should be soft enough to allow the distribution of the load over a reasonable area. And normally a plywood strip to 25 mm wide, 3 mm thick and 30 centimeter long is used. So here what is the main advantage of this method is that same type of specimen and the same testing machine are used for the compression test can be employed. Next is relationship between the compressive and the tensile strength. So what is compressive strength and what is tensile strength? So before going for the compressive strength and tensile strength, we should know the properties of compression as well as tension. And if we take a tensile strength of a concrete, which indicates the ability of the concrete to resist the tensile force which acts on the concrete member in the following form: direct tension, tension occurring because of the flexure; tension due to flexure, that is tensile stress developing in the concrete member when it is subjected to a bending loading. For example, bottom portion of a beam comes under tension comes under tension, the bottom portion of the beam. Another example, that is road slab. And here the measurement of the tension is not directly done, but it can be measured in the form of flexural strength. The next is flexural strength is related to compressive strength of a concrete member. Higher the compressive strength, higher is the tensile strength, but rate of increase of tensile strength decreases. The type of coarse aggregate influence the relation between compressive strength and the tensile strength of a flexural strength. Crushed aggregate gives relatively higher flexural strength as compared to the natural aggregate, and the addition of pozzolanic material increases the flexural strength. So obviously it increases the strength. So next, coming to the durability of the concrete. So what do you mean by durability? So durability is nothing but so durable. So if we take the common term durable, so how long it can resist. So ability to resist the weathering action is known as the durability. Durability of the cement concrete is defined as its ability to resist the weathering action or chemical attack, abrasion, or any other process of deterioration. So without any problem which undergoes, if the structure withstand for a longer time, it shows the durability or a period of lasting of a concrete. Durable concrete will retain its original form, quality, and serviceability when exposed to its environment. Significance of the durability. General awareness now that designers of the structure must evaluate the durability characteristics of the construction material under consideration as carefully as other aspects such as mechanical properties and so what are the significance of the durability? First, there is a better appreciation of socio-economic implication of the durability, and increasingly repair and replacement cost of the structure arising from the material failure. For example, it is estimated that in the industrially developed countries, about 40% of the total resources of the construction industry are being applied to repair and maintenance of existing structure and only 60% to the new installations. So next, if we go for the term permeability. So what do you mean by permeability? So if we take a fully compacted concrete and a partially compacted concrete, after the concrete get hardened, which concrete is more permeable? The partially compacted concrete is more permeable because there will be air void, so the water will percolate into the concrete. So that is the meaning of permeability. Permeability of the concrete, that is a factor under durability. Micro cracks at transition zone are a consideration for permeability. Water cement ratio may not get involved directly. Micro cracks in the initial stage are so small that they may not increase the permeability. But propagation of micro cracks with the time due to drying shrinkage, thermal shrinkage, and externally applied load will increase the permeability of the. So, what do you mean by permeability of the cement paste? So, we all know that after the hydration process, we get a paste or a gel known as CSH gel, that is CaOH2 and water filled or empty capillary cavities. Although gel is porous to the extent of 28%, the gel pores are so small that hardly any water can pass through under normal conditions. And the extent and size of capillary cavities depends upon the water cement ratio. It is one of the main factors contributing to the permeability of the paste. At lower water cement ratio, not only the extent of capillary cavities is less but the diameter is also small. And here, large cavities resulting from higher water cement ratio will not get filled up by the products of hydration. Cracks generated through higher structural stress. Cracks usually generated through higher structural stress as well as higher, uh, smaller aggregate size. Next is the sulphate attack. So, what do you mean by sulphate attack? So, soil contains some sulphates in the form of calcium, sodium, potassium, and magnesium. They occur in soil or granular water, groundwater. Because of solubility of the calcium sulphate is low, these occur. Sulphate solubility of calcium sulphate is low. These sulphate attack occurs on the surface of the concrete. Groundwater contains more of other sulphates and less of calcium sulphates. Ammonium sulphate is frequently present in the agricultural soil and water from the use of fertilizers or from sewage and industrial effluents. So, water used in concrete cooling towers can also be a potential source of sulphate attack on the concrete. Sulphate attack is a common occurrence in the natural or industrial situation. Magnesium sulphate causes maximum damage to the concrete, and the characteristic with which appearance is the indication of the sulphate. So here you can see the reaction of the various sulphates with hardened cement paste is as shown below. Let us take the example of sodium sulphate attacking CaOH2, that is CaOH2 plus Na2SO4 into 10H2O, which results into CaSO4 2H2O plus 2NaOH plus 8H2O, and the reaction. So this is about the sodium sulphate attacking. So you should remember all the equations. So they may ask you to describe or the reaction of the various sulphate with hardened cement paste, and the next one is reaction with calcium aluminate hydrate, and calcium sulphate attack only calcium aluminate hydrate producing calcium sulphoaluminate known as ettringite. Calcium sulphoaluminate aluminate, and molecules of water may be 32 or 30. So here you can see the cube again, or as like white powder form on the top surface of a concrete. The rate of sulphate attacks with the increase in the strength of the solution. A saturated solution of magnesium sulphate can cause serious damage to the concrete with higher water cement ratio in a shorter time. So when we go for any of the concrete project, and when we go for testing of a durability of the concrete, so we'll see whether it is attacked by the sulphate or not. So if white patches occurs on the surface of the concrete, it is nothing but the indication of the sulphate attack. If the concrete is made with lower water cement ratio, the concrete can withstand the action of magnesium sulphate for 2 to years. controlling. So if that sulphate attacks the concrete, what are the methods of controlling the sulphate attack? So use of sulphate resisting cement. Resisting the sulphate attack is to use the cement with a low C3A content. In general, it has been found that C3A, that is tricalcium aluminate content of 7% gives the rough division between the cement of the good and poor performance in the sulphate waters. Next is quality of the concrete. A well designed, placed and compacted concrete which is dense and impermeable exhibits a higher resistance to sulphate attack. Similarly, a concrete with low water cement ratio also demonstrates a higher resistance to sulphate attack. So next is use of air entrainment, that is nothing but a admixture about extent of about 6% has beneficial effect on the sulphate resisting qualities of the concrete. So next is use of pozzolanous. Incorporation of replacing a part of cement by pozzolanic material reduces the sulphate attack. Admixing the pozzolana converts the leachable calcium hydroxide, that is CaOH2, into insoluble non-leachable cementitious product. Secondly, removal of calcium hydroxide reduces the susceptibility of the concrete to attack by the lithium. So next is high pressure steam curing. High pressure steam curing improves the resistance of the concrete to the sulphate attack. Next one, the next property, that is use of the high alumina content cement, that is a type of cement, and this is like different methods, either by using pozzolanas or admixtures, or by with the help of other type of curing, or with the help of the type of cement, how we can control the effect of the sulphate attack. High alumina cement contains approximately 40% alumina, a compound very susceptible to sulphate attack when in normal Portland cement. But this percentage of alumina present in high alumina cement behaves in a very different way. The primary cause of resistance is attributed to the formation of protective films which inhibit the penetration or diffusion of sulfate ions into the interior. It should be remembered that high alumina cement may not show higher resistance to sulfate attack at higher temperature. So these are some of the topics under part 2 in module 3, hardened concrete, and here the points to be remembered, that is some of the relationship between the like compressive and tensile strength, and what are the tests done on tensile strength or compression test, and also you need to remember what is sulfate attack and the properties of the sulfate attack and how it can be controlled. So these are some of the important questions under this part 2 in module 3. Thank you.